This is lesson 3.1 on functions. The essential question here is, what is a function? A relation pairs inputs with outputs. When a relation is given as ordered pairs, the x-coordinates are inputs and the y-coordinates are the outputs. A relation that pairs each input with exactly one output is a function. So if we're looking at this example here, we're asked to determine whether each relation is a function or not, and if so, why not? So if we're looking at A here, if you look, every input, -2, 2, -1, 2, 0, 2, 1, 0, 2, 0. Every input has exactly one output. So the relation is a function. So what we're looking at is the x term are all different. -2, -1, 0, 1, 2. Even though the output, the y term, repeats 2, 2, 2, 0, 0. That's okay. Just the x can't repeat with a different y. So again, if we look at B here, we see that 4, 0, 8, 7, 6, 4, 4, 3, 5, 2. This one is not a function because if you look at 4, 0 and 4, 3, see the x, 4, is repeated with a different y. Therefore, this one is not a function. Let's look at C. The inputs, -2, -1, 0, 0, 1, 2. If you notice, the input of 0 repeats, and it has a different y. So this one is not a function. And if we look at D, this is kind of a little mapping diagram here. You think of the inputs is -1, 3, and 11, and the outputs are 4 and 15. Even though two of the inputs go to the same output, that's okay, as long as the input is not repeated or the input doesn't go to more than one output. So this is a function. So let's look at another example here. We're looking at, this is called a vertical line test. If we graph the function, a graph represents a function when no vertical line passes through more than one point on the graph. Meaning I can draw a vertical line anywhere on the graph, and if it touches more than one point, it is not a function. So if we're looking at these graphs here, if I'm drawing a line, does it touch more than one point? Right here, we touch 2 points. So A is not a function. How about B here? Wherever I draw a line, it's only going to touch 1 point on it. So this one is a function. So our core concept here is also to find the domain and range of a function. The domain of a function is the set of all possible inputs, all values of x I could use, and the range is the function of a function is the set of all possible outcomes, or the y's. So remember, domain will be the possible x values, and the range is going to be the possible y values. Input, output, x, y. Okay? So if we're looking at an example here of finding the domain and range from a graph, we're going to look here at these graphs. If you look at A here, we're going to write the ordered pairs and identify the inputs and outputs. So, our points here are -3, -2, 0, -1, 0. You must walk before you rise. Run before you rise. 1, 2. And 3, 4. So looking at these points, my inputs are, let me grab a different color here. My inputs are going to be the -3, the -1, the 1, and the 3. So to write remember the inputs is my domain. So the domain of this function is -3, -1, 1, and 3. Now, if we're looking at our range here, this -2, 0, 2, and 4 are going to be our range of the function. So to write the range is, I would write -2, 0, 2, and 4. Generally, when we're writing domains and ranges, you're going to start at the smallest value and go up to the largest value. So let's look here at the other graph here, B. We're trying to figure out the x values and the y values represented by the graph. Now the domain, like we said, is going to be the x values. So the domains are going to go from here to here. This is going to be the domain. And then the values for the range are going to be the lowest values here and the highest. This is going to be your range. So, to write that out though, our domain is going to be anywhere from -2, and we can use our x as I write y, our x here, up to and including 3. But our range is going to be our y here. I'm going to put a less than or equal to. And our range, the minimum, is going to be a -1, this point right here. Or our maximum is going to be a +2, which would go right there. So our range is from -1 to -2. You can write it this way. See, the difference is the graph A has distinct points, whereas graph B has a line connecting them, so it's continuous. So identifying independent and dependent variables. The variable that represents the input values of a function is the independent variable because it can be any value in the domain. The variable that represents the output of a function is the dependent variable because it depends on the value of the independent variable when an equation represents a function. The dependent variable is defined in terms of the independent variable. So the statement y is a function of x means that y varies depending on the value of x. So in this example here, y is the dependent variable, x is the independent variable. So now we can look here at an example that would help identifying independent and dependent variables. So we have this function, y equals -3x plus 12, and it represents the amount of y in fluid ounces of juice remains in a bottle after you take x gulps. So let's identify the independent and dependent variables. So the amount of y of juice depends on the number of x gulps. Therefore, y is going to be the dependent variable, and the x is going to be the independent variable. Okay, so now part B says the domain is 0, 1, 2, 3, and 4. What is the range? So what I would do here is just kind of make a chart. And I'm going to put my x value or input here. I'm going to have this equation that's negative 3x plus 12. And what my output will be. In other words, what the y is equal to. Because the y is equal to this negative 3x plus 12. So let's do 0, 1, 2, 3, and 4. Would it make sense to have a negative 1 or any negative values? No, it wouldn't, because any negative values would be that we have negative gulps. And we can't have negative gulps. So we're just going to rewrite this equation, subbing in these x values for my x. So, if x is 0, y is going to be 12. If x is 1, it's 9. 2, it's 6. 3, it's 3. And 4, it's 0. So, therefore, the range is going to be, these values. It's going to be 0, 3, 6, 9, and 12. That's going to be the range of it. When you finish with your notes, bring it up for me to check and get started on your Clever assignment.